Now, of course, I'm curious about how the predictions of this model turn out. Let's set up the actual values, the actual labels from our test data and the predicted values from our model in a data frame so that we can view them side by side. We'll now take a look at a small sample of actual versus predicted results, and you can see that almost all of them match. Our model seems to have done well, but what we really need is an objective way to measure the performance of our logistic regression model. Let's first set up a confusion matrix using the pandas crosstab function. This confusion matrix will plot the actual results versus the predicted values from our model. Observe that the columns are actual values from our dataset, 0 for when the passenger did not survive, 1 for when the passenger did, and the rows are predicted values from our model. You can see that most of the results are in the true positive and true negative cells, indicating that the accuracy of this model is pretty high. There are, of course, a few false positives and false negatives. Our model thought the passenger did not survive while he or she did, or vice versa. But we'll really only get a good understanding of how our model performs when we measure it using the right metrics. And for this, scikit-learn offers a metrics namespace with commonly used scoring metrics for different ML models. From sklearn.metrics, import accuracy score, precision score, and recall score. Each of these are functions that you can invoke by passing in the actual test Y labels from your dataset and the predicted values from your model. Use these functions to calculate the accuracy, precision, and recall of our logistic regression model, and let's print these scores out to screen. And here are our accuracy, precision, and recall values. All of them seem fairly high, indicating that this is a fairly good model. Remember that for binary classifiers, where you classify data into two categories, your classifier should have an accuracy of over 50%, because 50% accuracy is what you get when you guess at random. The accuracy of our model is 80.4%. This represents how many of the predicted values did our model get right. Here is the precision score of our model, 79.5%, again pretty decent. The precision score is a number that measures how many of the passengers that our model thought survived the sinking actually did survive. At 79%, there were very few false positives in our predictions. The recall score for this particular model is much lower than the other two scores, and this is a measure of how many of the actual survivors of the Titanic did our model correctly predict. This lowish recall score indicates that there were many false negatives in our predictions where our model thought that the passenger did not survive, but the passenger actually did. As you're aware, the accuracy, precision, and recall scores can be easily calculated using the confusion matrix. Here is the confusion matrix for our data once again. I'll now set up variables holding the data for each of our cells in our confusion matrix. The TP variable at cell 1, 1 represents the true positive predictions from our machine learning model. Our model predicted that the passengers survived and they actually did survive. The Tn variable represents the true negatives from our model predictions. Fp holds the false positives. Our model thought the passenger survived, but the passenger actually did not. And finally, Fn represents the false negatives. Our model thought that the passenger did not survive while the passenger actually did. You can see that this number is a little high, which is why we have a lower recall score. Let's use this confusion matrix to manually calculate each of the scores that we measured earlier using scikit-learn libraries. Here is our accuracy score, TP plus Tn, divided by the total number of instances on our test data. And here you see that the accuracy score that we get using manual calculation is exactly the same as the accuracy score from the scikit-learn library. So next time we'll just use the library. But it's helpful to check for yourself to understand really what these measures mean. Let's go ahead and calculate the precision score as well. TP upon TP plus FP. This is the true positive rate, and you can see that the precision score matches with the sklearn library as well. And finally, let's manually calculate the recall of our model, TP upon TP plus Fn, and this once again matches.